All right, let's look at this problem in force vectors and components of a force and vector addition and vectors operations. Find the magnitude and direction of the resultant force of these two forces, the 50 pounds that's going straight down, and then the 75 pounds that has a 25 degrees with vertical axis. This problem, we don't care about any of these links and all of that. That's probably going to be used in a different problem statement. All we care about is we have two forces, 75 pounds, that's making an angle of 25 degrees with vertical line, and then another force that is 50 pounds and it's going straight down. So what I'm going to do, again, different ways you can do this. What I'm going to do is write each of these forces. Okay, let's call this F1, let's call this F2. I'm going to write F1 as a Cartesian vector, means something I plus something J units of pounds. I'm going to do the same thing for F2 and then add them together. So F1 is 75 this is negative y, positive y, positive x, negative x, and it's making the angle 25 degrees right here. So the y component, go parallel to x, find the intersection, and wherever it connects, or sorry, intersects with y, that will be F1y. Go parallel to y, find the intersection, and this will be F1x. F1y will be 75 pounds, and then we go, because it's adjacent, we go cosine of 25. It's pointing towards negative y, so that's going to be negative. So it will be minus 75 cosine 25. F1x, different ways of doing it. You can say 75 and it's not adjacent to 25, so it will be sine of 25 degrees. Or if this angle is 25, 65, 90 minus 25, 65. Now it's adjacent to 65, so you can say 75 pounds cosine 65. Same thing. Every time if you're adjacent, right next to the angle, it's always cosine. Let's check the sign quick. Pointing to the positive x, so yes, it's going to be positive 75, positive 75. So 75, I'm going to keep it as sine 25. That's my F1. I'm going to write F2 as I and J. Just writing it quick here, 75 sine 25I plus, I keep the minus with it, so it's a little bit easier for you to keep track of. J, units of pound. F2 is a little bit easier. So it's a straight down, so there is no component of I. I still like to write it like this, and I just put a 0. You don't have to write it. And then when it comes to y, again, positive x, positive y. It's pointing against my positive y-axis, so it's going to be negative 50j, and the units are pounds. The reason I write this like this is because it's so easy to add the vectors together now. I add these two together, and that will be my resultant vector component. If you do the math on the 75 cosine 65 or 75 sine 25, you will get 31.69 I. And then if you do the math on these two, both of them are negative, so I expect to get a negative answer. I'm just going to put the negative right here. 117.97 J pounds. So this is my vector, resultant vector as a Cartesian vector. The problem says find the magnitude of it. Magnitude of any vector, I don't write the arrow anymore. Okay, just R, that means it's a scalar, that means it's a magnitude, is the square root of sum of the squares of its components. So 3169 squared plus 11797 squared, and these are pounds squared. If you do the math, you should get 122.15 pounds. If I want to write it in 3 significant figures, I can just write it 122. That's the magnitude. What about the angle? Okay, the angle, you can give the angle with x-axis, you can give the angle with y-axis. I'm going to draw a quick diagram here. I have my x-axis, I have my y-axis, I have 31.69 going in x direction. I try to represent the length of the lines I'm drawing kind of proportional to length of the vectors I have. And then in y, I have negative 11797, 118. That's going to be a little bit longer than that. Right there. And that's also pounds. As a result of these two, I already did that. Parallel, intersection. This is my vector R. And I did a squared plus b squared. I found this R to be 122. So now you can find either this angle and report it, or you can find this angle and report it. You can find any angle and report it, and that will kind of define the direction of this force. I'm going to use theta, angle of R with positive x-axis. Look at this angle. If I want to write this angle in this triangle right here, 30. Let me just go with 32. Just for simplicity, you please use 31.69 and 117.9. I'm just for simplicity, I'm going to write it like this. In this triangle right here, tangent of theta would be this over this. So 118 or 11797 pounds over 32 pounds. Okay, this will give you about 3.79. So tan inverse should get you theta of 74.96 degrees. 3 sig figures, I can just write it as 75 degrees. Again, you can find alpha, you can find any other angle you want. You can even find this angle right here. That's totally fine. So any angle that you find, it will define this vector and its direction. I hope this was helpful.